Hello and welcome to this applied ion testing exam question. What this question requires you to do in particular is to process and make conclusions from a description of a procedure that's given in the question. So it gives you quite a lot of text there, so we'll deal with each step at a time. So then it says a student is provided with a solution containing two different sodium compounds. The student carries out a series of tests below in the mixture, as described. And then it says in part A, what conclusions can be drawn from these tests include the formula of any ion identified and equations for any reactions which take place. And the second part, part B, the second student carries out the same sequence but adds dilute sulfuric acid in the first step instead of dilute nitric acid. They continue with a series of tests and obtain a different result, and they come to an incorrect conclusion. State and explain the second student's different result and the conclusion, and include an equation for any different reaction. So first of all, let's visualize what that yellow highlighted part means. You've got a solution, a single solution containing two different sodium compounds. So it's one test tube, not two separate ones. So let's now imagine we're adding dilute nitric acid to that. So what you would see is effervescence bubbles will start to form in the mixture. And then what happens is test number 2. You add aqueous barium nitrate, so you change your pipette to another one. So imagine that the pipette now contains aqueous barium nitrate which is being added. And what would happen is nothing. Well, we wouldn't say nothing because we don't know for sure that nothing is happening. So what we say instead, which is quite important, is no observable change. So it might occur to us that nothing has actually happened, but can we really tell that because we can't see exactly with our own eyes what's happening at atom and molecular and ionic level. So what we say is no observable change. So test 3 is adding silver nitrate in aqueous form. So a third of the solution now, still added to the same test tube. New pipette with new solution, and you get a cream precipitate now forms. Now if we were to add some concentrated ammonia to that test tube, that precipitate would dissolve, which confirms it's a bromide. So we can make some conclusions now in answer to part A. So test 1 is the carbonate ion, so that's our conclusion. We can write an equation like that, showing the carbonate, sodium carbonate, reacting with HNO3 to make sodium nitrate, carbon dioxide and water. Or we can simply write it as an ionic version of that equation by getting rid of spectator ions such as sodium and nitrate from either side. Test 2, neither sodium compound contains a sulfate ion, because if they did, you would get a precipitate, a white precipitate, because of the barium. In test 3, the bromide ion is present, we just said, so the other compound must be NaBr. So the two compounds are sodium carbonate and sodium bromide. Remember, it's a solution containing two different sodium compounds. So we can do an equation for the reaction between the sodium bromide and the silver nitrate, and we can also write an ionic equation to that, cancelling out the sodium and nitrate once more as spectator ions. So now what happens is we imagine that instead of nitric acid being added, it's sulfuric acid being added at the beginning. Now, this time, if you add aqueous barium nitrate, you'll get a white precipitate because you'll form barium sulfate. Where does the sulfate come from? It comes from the sulfuric acid. So this is a new observation that we have to try and explain. So in test 1 you'd still get the effervescence, so the same equation except this time it's sulfuric acid you'd react the sodium carbonate with, and you'd make sodium sulfate, giving the same overall ionic equation. In test 2, the white precipitate is due to the reaction of barium 2+ with the sulfate ion to make barium sulfate. In test number 3, you wouldn't get any different observations, so I'm not going to write any new equations. I've already written the equation for what happens in test number 3 when I did my answer to part A. Okay, so hopefully this has been a useful clip, thinking about how you might be able to navigate your way through a slightly more complex problem-solving type question like this. Until next time, thanks for listening, and see you soon.